Hi, today we're going to go over section 6.5 in calculus. And we have for many lessons been talking about derivatives and how to find them. And we really haven't talked too much about the purpose of them. And today we're going to talk about one of the purposes of derivatives, and that is to help us in graphing. So the first slides here are just general things about graphs. And it'll lead us to some information about the derivatives and graphs. So the first question is, for what x values is f of x increasing? So this is my function f of x. It's increasing from here until I get to here. Okay, that starts where my x is a -2, and it stops where my x is 1. So here's my first answer. X has to be greater than a -2, but less than 1. Okay, there's another spot where it's increasing. Starts here at an x of 3. And it continues to increase here. And at the end, that means that there's really an arrowhead there. So that's an increasing function from 3 on. So I say that's when x is greater than 3. For what x values is f of x decreasing? So let me see if I can change the color of my pen here. It's decreasing from forever until it gets down here. So from ever until that -2. So that would be all the x's less than on -2. Okay, where else is it decreasing? It's decreasing from here to here. And what x values does that go with? From a 1 up until a 3. So my x is greater than a 1, but less than a 3. Okay, more of this kind of stuff. At what x value or values does f of x have a relative maximum? So a relative maximum means that it reaches a peak, like a mountaintop, like over here. And it's a relative maximum because you could have other spots like that on the graph. It might not be the highest. So relative maximum is, it comes to that peak, but it might not be the greatest peak of the whole graph. So that happens right here at an x of 1. At what x value or values does f of x have a relative minimum? Here's a relative minimum. That occurs at an x of -1, -2, right there. And where's there another relative minimum? Over here. And that occurs at an x of 3. At the points where f of x, where the graph of f of x changes from increasing to decreasing. So let me get a highlighter. Where f of x changes from increasing to decreasing. So increasing to decreasing, right there. At that spot, it has a relative maximum. At the points where f of x changes from decreasing to increasing, it has a relative minimum. And here's another spot. It changes from decreasing to increasing over here. And that is where it has another relative minimum. What do you notice about the slope of f of x when f of x is decreasing? So we know this from algebra 1. When a graph is decreasing like that, the slope is negative. So here there would be a negative slope also. What do you notice about the slope of f of x at the relative maximum and minimums? Okay, let me get a pen. So right here is a relative minimum. The slope at that point, the tangent line right there, that would be 0. Over here, slope of 0. Here, a slope of 0. And then, what do you notice? Let me get a different color again. What do you notice about the slope of f of x when f of x is increasing? So when it's increasing from algebra 1, we know that that means it has a positive slope. Here we have a positive slope. This is pretty easy so far. Now, at this point, they give us a bunch of steps, and I'm not going to wait for everybody to write down these steps because they're going to be on your class notes. So I'm just going to walk through them a little bit and see if I have any comments in any of them. What you want to do is find out where f of x is increasing, where it's decreasing, where it might have a relative maximum, and where it might have a relative minimum. So the first step is you find the derivative of f of x, because the derivative is the slope. So if the slope is negative, it's decreasing. If the slope is positive, it's increasing. If the slope is 0, that's where it might have a relative maximum or minimum. So the slope is very important in this, and that is the derivative. So first step, find that derivative. Then set the derivative equal to 0 and solve for x. These points are called critical points, and they are the points where relative maximum and minimums can occur. Place those critical points on a number line for the slope, and pick test points between the critical points and sub them into the slope to find if the slope is positive or negative. So you're going to get a number line that has positive marks and negative marks, and these critical points where the slope is 0, showing you what the slopes are of all the sections of the graph. We're going to have 2 examples of this when we're done with these steps. Fifth step, f of x is increasing where the slope is greater than 0 or it's positive. F of x, the graph, is decreasing where the slope is negative, less than 0. And step 6, where f of x goes from increasing to decreasing, there's a relative maximum. Where f of x goes from decreasing to increasing, there is a relative minimum. So if you picture this from increasing to decreasing, it's a maximum. From decreasing to increasing, it would be a minimum. Okay, 2 examples. Find the intervals on which f of x is increasing and decreasing. Find and classify relative extrema. That means relative maximums and minimums. So my function, f of x, is given to me, and I can see I'm going to use the power rule on all 3 of those terms to find out what the derivative is. So the derivative is 3 times 2 is 6, keep the x, lower 3 to a 2. 2 times a negative 3 is a negative 6, keep the x, lower the 2 to a 1. And this one, remember, if there's just an x, it's just going to be the number and sign in front, so it's going to be a negative 12. So that is my derivative, and that's going to be the slope. So the first step is take that derivative and set it equal to 0. So that's what I did in this step over here. Next, I looked at that and I said, look, 6, 6, 12, 0, they can all be divided by 6. So I divided everything by 6 in this step so that my numbers were smaller. Then I needed 2 numbers that multiplied to be a negative 2, that added to be a negative 1. And those 2 numbers were a negative 2 and a positive 1. So I put those into parentheses here and here and set that equal to a 0. Okay, if 2 parentheses multiply to be 0, either the first one is 0 or the second is 0. When I solve, I get these 2 as my x's. Put those on a number line. So here is x is a 2, here is x is a negative 1. Then test some points. So I tested something less than a negative 1. I chose a negative 2. I put it into the slope, into the derivative up here. And when I did that, the answer became positive. When I chose something between negative 1 and 2, I chose a 0. When I put the 0 in, I got a negative 12. Okay, that's a negative section. Okay, the section past the 2, I chose the number 3. When I put the 3 in there, I got a positive answer. Okay, so that means that the slope is positive or increasing up until you get to an x of a negative 1. It is decreasing when the x's are from negative 1 to 2, and it is increasing again, going uphill after I get to a 2. So that's what I wrote over here. Okay, my relative maximum is at a negative 1. I found that out back here. But I don't know what the y is. So I chose the original equation right here and put in my x of a negative 1. And when I did that, I got my y of 7. So I know at a negative 1, positive 7 right up here, I have a relative maximum. And I have a relative minimum when I have an x of 2, because the graph goes from decreasing to increasing, from a negative slope to a positive slope in there. And so therefore, where is that in terms of y? You'd have to go back and put that x of 2 into the original f of x. So that's what I did over here to find out that y is a negative 20. So when x is 2, y is a negative 20 down here. Okay, so it's increasing when x is less than a negative 1 until it gets to that point, negative 1, 7. It's decreasing when I go from an x of negative 1 to an x of 2. So when I go from that point of negative 1, 7 to the point 2, negative 20, and then beyond that point, it's increasing. And that's what gets me the shape of that graph. Okay, last one is kind of the same thing. It just has one little weirder thing in it. Find the intervals on which f of x is increasing and decreasing, and classify any minimums or maximums. So this is the function. F of x equals x plus 2 to the power of 3, and then x minus 1. I notice that that is a product. There's a multiplication here. So for a product, the derivative is f g prime plus g f prime. So that's what I'm going to do over here. F is this function. I write it over here. Times the derivative of g. So the derivative of x is 1, and the derivative of negative 1 is 0. So this is just going to be a 1. So I put that here. Then I have a plus sign. G, so x minus 1. And then the derivative of f. This is a function raised to another function. So therefore, this is the chain rule. So 3 goes to the front. I keep the parenthesis, lower the exponent by 1, so 3 becomes a 2. And then multiply by the derivative of the inside. So the derivative of the inside, that's a 1 there. So it's going to be a 1 plus 0. So just a 1. Okay, then I just did some algebra. When I multiply by 1, I just get the parenthesis to the third power. And here I took the 1 and the 3 and the x minus 1 and multiplied those all together to get 3x minus 1 times the parenthesis x plus 2 with a square on it. Then I notice that there's an x plus 2 to the third and there's an x plus 2 to the second. So I factored out the x plus 2 to the second. If I take 2 of them out of this first term, I'd have 1 left over, 1x plus 2. And over here, if I take the x plus 2 to the second power out, I'm left with 3x minus 1. So I distributed and got 3x minus 3. Okay, the first one I left. The second one I grouped up the x and the 3x and got the 4x. 2 minus a 3 is a negative 1. So that is the derivative, and then I set the derivative equal to 0. So if those two parentheses are equal to 0, one of those has to be equal to 0. So here x would have to be a negative 2, and here x would have to be a positive 1/4. I put those on a number line, and then I test the points. So here I am testing the points over in this section here, and I find out that this is negative, and this is positive. So on my graph, my critical points are at an x of a negative 2, which is right there, and an x of 1/4, which is like over here. Okay, then I look, and when I am looking at this negative 2, it's negative before it and negative after it. So it's going downhill, and then it hits that point, and it goes downhill again. Okay, now what's happening over here, I guess I should have talked about this a little bit. How do I know what this y value is that goes along with the 1/4? I plug it in. So I took my function and plugged in a 1/4, and I get a negative 8.5 as a y. So that's how I know how far down that one is. Okay, then I go back and I say, okay, from here it was negative and then it went to positive. So that means from here it was going downhill, but now it's going back uphill again. And it's going to continue on doing that. So there's an arrowhead here, and this actually is an arrowhead over there. So that's how derivatives can help us graph some complicated looking equations. So I hope you learned something from this. I hope everyone